Okay, so you guys have talked about area in the past, right? So area, we can think of area in terms of little squares, right? So if we have a square, the area, we can think of it as a bunch of little tiny square units. So area is little squares or units squared. Okay, but today we're talking about volume, which equals little cubes or units to the third power. So what we have, if you think about like for example, sugar cubes. So has everyone in here seen a sugar cube? Probably. Mm-hmm. Yep, okay. So yeah, so it's just measuring, it's a three-dimensional unit. So instead of having so since it's three-dimensional, to get volume, the reason why it's units to the third is because we're taking the area of one face, like this square here, and then we're multiplying it by its depth as well. So for here we have, if we had, say, x width here, we would get x squared, because it'd be x times x. But in this case, we have the added dimension, which is also x, so then we get effectively here x to the third, or whatever our units are to the third.
So when we're looking for volume, what are we finding? I mean, now we're thinking about volume, if it's three-dimensional, what are we finding if we think of our prisms or pyramids? What are we finding?
Are you finding the faces on it, like the area of each face?
No, that's surface area. That's what we have it doing. Okay, so what do you think? What do you think that he says it's called volume? What is volume?
It's like a cup, how much water will fit in the cup.
How much will fit in, and we're doing it from a measurement standpoint that's not like liters or cups or that kind of stuff. We're doing it by how many little cubes fit inside. So if you have an inch by inch by inch cube, how many of those can fit inside whatever you have, okay? Area is just how many little squares. There's no third dimension to it. It's just flat, and it's how many little squares will fit inside. Volume is three dimensions, which means you're going to get that third dimension. So now we're looking at how many cubes fit inside that whole figure, okay? That's why it's units cubed when you're working with volume.
Okay, so big idea. Volume of a prism or cylinder equals the we'll call it B times H. So in this case, this is the area of the base of the object. And this is the height. So let's see if we can do an example here. This is gonna be fun. Okay, let's see here. So let's imagine we have a swimming pool. So the swimming pool is 20 feet long. So we'll say it's 20 feet long, 16 feet wide. Um, 10 feet deep at one end and 6 feet deep at the other. Okay. Oh boy. Hopefully this drawing is going to work out. And 6 feet.
I think you need to make it 16 feet and then 6 feet.
Wait, with these would, wait, what am I doing wrong here? So it's, okay. So this would come down, right? Then it would still be 6 feet deep, right? So we have something like that. Is that making sense, sort of, kind of?
Yes.
Okay, all right, so if we want to find the volume, oh wait, there's some other details here. Assume that the walls of the pool are perpendicular to the opening, and the opening is a rectangle. Okay, so this here is a rectangle, right? So we want to first figure out what the area of this shape here is. So okay, so that's going to be, because effectively what we're going to do is we're going to take this area and then we're going to multiply it by 16 feet, right? Does that make sense to everybody?
Mm-hmm.
And then that'll give us the volume. So what's the area of this? Anyone know? How would we find that?
You make it into a triangle and a square, so you take 4 is the triangle, so 4 times 20 divided by 2 plus 6 times 20, and that would equal how big it is.
Okay.
So it would be 4 times.
So is it 1/2 the height times B1 plus B2?
Or I had it over 2, but either way.
Right. Okay. That's how you've been doing it. Yes. So like that. Okay. So that's gonna be. Okay. So our height effectively. Let's see. Am I doing this right? So I have that the height is 20 feet, and then 10 plus 6. Is that right?
Is that a half or is that 2? Are you dividing?
This is, we're dividing by 2. So yeah. So would these be our bases?
Yeah, because those are parallel sides.
Right. Okay. That's what I was thinking. Okay. Okay. So it's gonna equal 20 times 6 plus 10 divided by 2. So that's 20 times 16, which would be what, 320? Yeah, 320 over 2, which equals,
160
yep, 160.
times 16.
Right, we're not quite to that point yet. So what would the units be for this?
Feet squared.
Yes, feet squared. Very good. Feet squared. Okay, so then for the volume, V will equal what?
16 feet is the volume, or how deep it is.
Yeah? Or wait, yes. Okay, and then that's going to be multiplied by what?
By 160,
By the 160, yeah.
that's 2,560.
2,560? Okay.
Yeah.
And what are the units for this?
Feet cubed.
Feet cubed, yep. Yeah, so again, so what this is going to equal is how many sugar cubes that are 1 foot by 1 foot by 1 foot that can fit into this swimming pool. So you could figure out what your water bill would be to fill your swimming pool. Okay, so new big idea. So volume of a cylinder equals, it's still the base times the height, but we're going to specify how we calculate that, right? So that's going to be pi r squared times the height. So this, right, this expression here is just the area of a circle. So it's basically, that's why this has the same form as the volume of a prism. So let's imagine we have a can of soda. So the can of soda okay, the can of soda is 12 centimeters tall.
Not very tall.
That's pretty tall, actually, isn't it?
Not bad.
Be 6 inches tall. Okay, it has a radius of 3.2 centimeters. So the radius is 2, or what did I say it was? 3.2. 3.2 centimeters. So volume equals what? So think about this. So what would be the first step here?
What did you want to figure out the area first?
You want to figure out the area of either the top or the bottom, which are the same in this case. So what would the area be?
You would do pi times 3.2 centimeters, and then you would want to square the radius.
Which is 3.2 is the radius, right? Okay, so yeah, so it would be pi times 3.2 squared, yeah.
And that's 32.16.
No, it's not. 3.2 squared is not 31.
No, I was saying times pi.
Oh, well,
It was
take it
ten-
one step at a time. Don't do it all
10.24.
together.
Okay, so what is 3.2 squared?
Pull out your calculators. Everybody try to
Yes,
see if
somebody-
they can get 3.2 squared on your calculator. What is the answer?
10.24.
Okay. Letting
Okay.
everybody check.
Times pi, what is it? Is that what it is after times pi?
No.
No, just, I want
Oh.
everybody in the room to check their calculators, make sure they can get 3.2 squared. Okay, tell me what you got. Come on, just speak. Lil, what'd you get?
24.
Okay, what'd you get, Gavin?
Oh, so.
Okay, don't times it times pi. All you're doing is 3.2 squared.
Yeah, I got that too.
Okay,
So we got 10.24 for this part?
and then I do not want you to use 3.14. I want you to use the pi button now. So multiply it by the pi button. Can you find that on your calculator?
Guys, that
Just a sec, I want him to find it. Okay, what did you find? Okay, go ahead and say it, Branson.
32.16990877.
Okay,
So
round it to the nearest hundredth,
32.16.
okay? Is that what you guys got? Lil, is that what you got? Okay. Hayden, is that what you got?
I can't.
Oh, that's right, we didn't give you a calculator, I'm out of calculators, okay.
Okay, so what's 32.16 times the height, which is 12, right?
Please don't write times that right there.
Or is this gonna confuse them?
No, that's not correct. So now take 32.16 times the height.
And we get,
It's 85.92.
okay, so I'll just round it to 386. And what are the units?
Centimeters cubed.
So can you imagine a centimeter? So a centimeter high, a centimeter wide, and a centimeter long. That's how many you can get is 386 centimeters cubed in there. How many of those will fit in there approximately? Okay. So when you're doing this, you're doing the area of the bottom first and then multiplying it by the height. That's always the way you do it. Find the area of whatever the bottom is. Well, in this case, the cylinder. I guess we're not doing prisms right now, are we? We're just doing.
At this specific moment, yeah, we're
Yeah,
just
okay.
working on cylinders, yeah. Okay, now we're continuing our theme, except we're gonna talk about spheres. Okay, so this is 11:8, just to keep you. So we have two figures here. We have this. Well, what is a sphere? Basically, it's all the, what do you say, points at an equal distance from a center? Yeah, so,
In 3D.
yeah, in 3D.
Circle.
It
Yep.
really is.
Yeah, that's a good way to think about it. So for sphere, we have two different items to calculate. We have surface area equals 4 pi r squared, and we have volume, which equals 4 pi r cubed over 3.
What's the difference between those two? Gavin, what is surface area? What are we finding if we're looking for surface area?
Oh, like the, not the inside, but kind of like the face of the shape.
Okay, so it's in a sphere,
The outside.
It's the outside of that shape. So surface area, and notice it's only in square. It's measured in square little units, square centimeters, square. So it's how many little squares would actually fit around that whole shape. The outside of the basketball, the outside of the volleyball. That's what we're looking at.
Is surface area and perimeter the same thing?
No, perimeter is just distance around. Surface area is actually area, but in a 3D figure, you've got many different faces that have it. And this one is all round. That's why it has pi in it, okay? What is volume? What are we actually finding in volume? Lil, what are we finding in volume? So we're looking at the volume of the sphere. What are we finding? What was volume when we talked about it before?
The inside of something.
It's the inside, and what are we measuring it in? What are we looking for? How many what fit inside it? How many cubes?
Yep.
And they could be cubes of an inch by an inch by an inch, or they could be cubes of a centimeter by a centimeter by a centimeter, or they could be really big cubes, and they could be a foot by a foot by a foot. Okay, those are big cubes. Okay, and so it could be something like that that you're looking at. Okay, so go ahead.
Okay. So, for our first example, we are going to estimate the total surface area of Pluto. So, not to be confused with my sister's doll. She has a little Yorkie named Pluto. Okay, let's see here. So, Pluto. Pluto radius equals 737 miles. Okay, so what is our formula for surface area? I just erased it.
But was that like was that a 4? Is that what it was?
Yes,
It was, okay.
4 pi r squared. Yep. Okay, so in this case, that would be 4 pi 737 squared. It's gonna be a big number. Okay, so what do you get? Remember, for pi, make sure to use your pi symbol and not.
What order would you do that in?
Yeah, that's a good point.
PEMDAS, so.
Yeah, what would you do first?
737 squared.
Yep.
Yep.
Do that first. Do 737 squared, then multiply it by 4, then multiply it by pi.
Yep.
All of you do this on your calculator. Come on, you guys have calculators, I see them. Let's use them.
Are we just squaring 737 over?
Sure, you can do that right now. Then we'll take it a step farther. So they're just squaring through 737.
Wait, so am I doing 4 times pi times 737?
We're doing just 737 squared right now. I'm gonna put that number in here, right? What is 737 squared?
I got 543. Wait, 543,160.
Okay. And that equals, so 4 pi times that equals what? Or that times 4 times pi, however you wanna. Everybody do it.
$6,825,662.
And this would be, what would be the units?
0.96. Miles cubed.
So I'm gonna round this up. So yeah, miles cubed. So our sugar cubes in this case are 1 mile by 1 mile by 1 mile. So they're pretty big sugar cubes. So that's a lot of surface
Can you
area.
even visualize 1 mile by 1 mile by 1 mile?
No.
I can't either.
Yeah, I can't either.
So that's how big Pluto is. It's that many million of those. That's a big planet. Not as big as Earth, but it's a big planet.
Okay, now we want to do volume. So,
I thought you just did volume.
no, we just did surface area. Right?
No,
Is
that's
it
one.
miles squared?
Yeah, it was miles squared. Wasn't it? Or did we do?
Oh,
what
yeah,
did-
you did. No, you did surface area, sorry. I lied. Yes,
it should have been miles squared.
Yeah, it was.
Okay. Yeah, so now we're doing ping pong ball. So volume equals 4 times pi r to the third over 3. Okay, in this case, the ping pong rules state that a ball must be spherical with a diameter of 40 millimeters. So if we have our, anyone know how to draw a sphere? Do you know how to draw a sphere? No, okay. Okay, so if our diameter is 40 millimeters, what would our radius be?
Wait,
The diameter of the sphere is 40, so what would our radius be?
20.
Yeah, 20, yeah. So r equals 20. Okay, so we're gonna have, what is 20 cubed? Well, 20 times,
8,000.
what?
8,000.
Okay.
Ask Will or Mercy to do the next part.
Okay, go for it. So 8,000 times 4 times pi.
I got 100,530.9649.
100,000, what was it?
530.
Excuse me, grandson. Marcy is doing this. Please don't interrupt.
0.96.
Okay. What's that number divided by 3?
33,510.3.
Okay, and this is gonna be millimeters, right? And what to what power?
Third?
Yeah, because we're doing the volume, so we're looking for little sugar cubes that are 1 millimeter by 1 millimeter. I think that's pretty small, isn't it?
Very
Relatively small.
Very, very small.
That makes sense because the ping pong ball is quite small.
Yeah.
That's 4 centimeters by 4 centimeters. Because 40 millimeters or every 10 millimeters is a centimeter.
No. A millimeter is 1/10 of a centimeter.
Yeah, so
Yeah.
every 10 millimeters is a centimeter. So if you take 10,
A centimeter is 10 millimeters.
yeah. Or 10 millimeters is a centimeter.
Yes, that works. Okay.
Okay, so let's try something different here. So what happens if instead of doing this in millimeters, we do it in centimeters?
Okay.
So if this is in millimeters, what is the radius in centimeters?
2.
Because there's 10 millimeters in each centimeter.
Correct. Okay. So in this case, we're gonna have volume equals 4 pi times 2 to the third. So that's gonna equal
Divided
4.
by 3.
Yes, sorry. So that's gonna be 4 pi times 8, right? Over 3. So that equals what? 32 pi over 3?
Have one of them get that answer.
So what's
Hey, Lil, get that answer for us.
Just the top, or we still dividing?
All of it. Yeah.
go ahead and do the whole thing, yeah.
2.09.
No?
No?
Try that again. 32 times pi.
Oh, I forgot.
Oh, okay.
$33.5.
And what are units? They are cubed.
Centimeters
Oh,
cubed.
and we're
Yep.
doing centimeters. this time.
Interesting. Big difference, huh? It's because it's a exponent, so it gets much bigger, or it gets much smaller in this case, yeah.
Are we gonna break?
Soon, yes. Let me finish one more example here.
You could just go ahead and give them a break and
Go ahead and give me a break.
have them come back and we'll work on stuff.
Okay, go ahead and take a break.
Then we can.